artificial intelligence is very well suited to a data set like satellite imagery, because there are petabytes and petabytes, if not more, of this data that will be coming down from these satellites, and no human can possibly sit down and go through all of that. So we need to build these AI models that can go through all of that data and monitor the minutest of changes that are happening, so that we can take better action, whether that's border security, whether that's agricultural farms and the yield of crops, whether that's oil and gas leaks or pollution sources, being able to detect where they are from, being not only where they're emanating from, but being able to detect the changes that will occur across different months and years. That's where AI really plays a big part. SatSure has been using AI in their analytics models for the last few years. Pixxel has an AI platform called Aurora, where we have a lot of these models already built in, and each of us will bring to bear these capabilities to make sure that a combination of these four data sets, very high resolution data, hyperspectral data, SAR data, and multispectral data, can be combined to provide a holistic view and not just a single point of view that any one single data set gives. Also, with the recent developments with large geospatial foundational models, in the same vein as there are large language models, there are a lot of these large geospatial foundation models that are being trained similar to LLMs, where you can not only use a text-based interface to just go in and type the query that you want from the satellite data, and the platform will do it for you. For example, if the municipal corporation in Bangalore wants to know what's happening with the lakes, all someone has to do is type, tell me what the water quality parameters have been in the lakes of Bangalore for the last 2 years. The platform will automatically figure what images, it will automatically figure what dates, and automatically figure what model to use, and then churn out a report without having to do anything in between, which makes it very accessible and easy and ubiquitous for people to come in and use this data. And more importantly, I think once the reports have been generated on what has changed and what you're looking at, it can help make the understanding of the outputs easier as well. So a customer could just upload an image to an AI program and ask it, hey, what am I looking at here? How does this parameter affect what I'm trying to do, etc., etc. So I think that's where the AI will play a very critical part with the satellite imagery and the downstream applications of it. So whether you're looking at farms, for example, right, and the Ministry of Agriculture, let's say, wants to understand what's happening with rice in the country, all it has to do is type, tell me what the potential yield for rice is going to be this year, and the model will figure out what data to use, how to combine it with rainfall data and historical yield data, and then churn out an answer that will tell that within this error range, this is the expected yield for rice that will be this year, so that the government can plan accordingly what to import or export and sort of how to prepare for the storage of it. Very similarly, if someone's trying to find out what is the cause for increasing AQI in New Delhi, you could go into the platform and type, tell me all the point sources of greenhouse gas emissions within a 100-kilometer radius of New Delhi, and then you can start identifying what could be those sources. So all of these data set gives us different methods to convince policymakers to sort of start taking better care of our planet in various different ways. Yeah, I think orbital data centers are going to be in the future of humanity at some point. Very hard to comment whether that will be in 2 years or 5 years or 20 years. But people have been talking about Kardashev scale 2, which is basically being able to build a Dyson sphere and utilizing the complete power of the sun that we have in our solar system. And no better way or place to get access to all of that power for almost free than in space, without having the mitigating effects of the atmosphere. It won't replace the on-ground data centers, so those will continue to be, but as we start running into problems with power generation and with the other outcomes that come out of it, being able to just put GPUs and compute on satellites and launching quite a few of them and utilizing the free solar power that you get there, we could take images of a certain area, and the image doesn't even have to be downlinked. It could be something that could be completely analyzed in orbit, and only the report or the insight can be sent. So one example is if let's say the use case is counting the number of ships at a port, you don't have to download the image and send it to someone and use a model. The model could be run on the satellite, and it could just beam down a number 9, right? So you would know that if you're looking at the port of Mumbai, there are X number of ships there. So I think that's what orbital data centers will enable. A big use case of that will be analyzing data that is being captured in space and being beamed down to Earth, but it will also go beyond that for AI heavy computing and training that we'll continue to see, I think, for the foreseeable future.